8.5. Proving triangles are similar.
Oh my gosh, bro.
Alright, in these exercises we're going to determine which 2 of the 3 given triangles are similar and then find the scale factor for the pair. So you may have to try all 3 pairs before you find one, but once we find one that's similar, then we don't have to find any others because there's only going to be one that is, like one set that is. So number 6, they're going to give you 3 triangles to look at. Why are you late?
Took a little longer than I expected in the rush.
All right, so we have these 3 triangles, and then we need to try to see which ones are going to, or like which ones are going to be similar. So you can either try to kind of look at them and say, okay, well, these look like maybe they could be, and go about it that way, or you can basically just trial and error. But obviously we don't know like which order the letters go in, but the way that we would obviously have to assume is that the biggest or the longest side goes with the longest side of the other one, and so on and so forth. So let's try the first 2, and we'll compare these ones. So I'm going to write it out in letters first for this one, and the ones after that we'll probably just just do the numbers. But I'm going to start with JL over MP. And that should, in theory, be equal to, if they're similar, then KL over NP. And that should also be equal to JK over MN. So then I'm just going to fill in those with their numbers, and then we'll reduce them down. Because a lot of these have like decimals in them, you're probably just going to need to use your calculator and see what they're equal to. When we do like our scale factor, then that obviously should be not a decimal number. But otherwise, for finding out if they're similar or not, we can just do it this way. So this is 12 over 7.5 is equal to 8 over 6 is equal to 6 over 4.5. So 12 divided by 7.5 is 1.6. 8 divided by 6 is 1.3. At that point, I could basically stop because I know that they're not the same. And then 6 divided by 4.5 is also 1.3. But because this first one is not equal to this, then these ones are not similar. So that means I need to try another one. So then I'd probably just go to the next 2 in line. And so I'm going to look at MP over SQ, and then PN over RS, and then MN over RQ. So this would be 7.5 over 5 is equal to 6 over 4 is equal to 4.5 over 3. And then I would find these ones again. So this is 1.5. This one's also 1.5. And so is this one. So if these are all equal, this means that they are similar. So then my similarity statement would be that triangle, and it doesn't, as long as you like start in like the order and you go about it the same. So I'm going to start at the bottom and then go up and around this way. So MNP is similar to triangle, going the same way. QRS. So that's the similarity statement, and then they want the scale factor. And so the scale factor is written as like a number and then a colon and then another number. So the only one of these that I can like directly reduce down is this 6 over 4. And what would that reduce to? 3 over 2. So this would be 3 to 2. And this should be in the same order as like the order that you have your triangles. If you wrote them like flipped, then you would write 2 to 3. But usually we write like the bigger one on top. So now I found the one that's similar. I don't need to keep going. If that one didn't work, then I would compare the first and the last one. And if you get to the point where none of them work, then you need to check your math because you've probably done something wrong. Number 8. So compared to the last problem, what do you notice about these triangles? Or say that again, I just didn't hear you.
They look the same size. I don't think that's right.
I mean, yeah, they kind of look the same size, but what about the way they're positioned?
It like makes a shape, makes another shape.
They're like all different positions. Like the other ones, MP and RSQ look like similar.
Yeah, so in these ones, they were all kind of positioned the same direction. Like this was the longest side over here. But in this one, my longest side on this one is down here. On this one, it's up here. And this one, it's down here. And then the first and the last one, they kind of looked like they're like almost reflected of each other. The only reason I'm pointing that out is you just need to be careful when you go about doing your problems, because you need to make sure that you're paying attention to like longest side with longest side when you're setting this stuff up. Okay. So I'm gonna let y'all decide. Which 2 triangles do you want to start with?
Two sides outside.
These 2?
Yeah.
Okay. All right, so longest sides. So we'll go XY over, longest side over here, ST. And then the next side, YZ over SU. And then XZ over UT. So then plug in the numbers. And again, if you don't write the letters, like that's fine. I'm just doing it right now so that we can see it. A lot of times I just go straight to the numbers. But so this would be 33 over 44. Now notice, I kind of like flipped it this time and I did the smaller one on top. That's fine. They should still be equal. Okay, the decimals are just going to look different because of the way that they're written. And then 27 over 36. And then
18 over 24.
18 over 24. If you can reduce, obviously it's good to go ahead and do that.
First one.
Yeah, since these ones don't have decimals, let's reduce them. We still may need to like type them in, but what would this one reduce to?
4.
Huh?
3 over 4.
3 over 4. What about this one?
3 over 4.
3 over 4.
3 over 4.
And this one is also 3 over 4. So sometimes there was one of them that I reduced in a different problem, and I could reduce the stuff down, but it still didn't give them to like all be something that was like essentially looking equal. But I think it was because there were like some decimals in there. But anyways, so I still needed to do the decimals. But 3 over 4, these are all equal. So you chose wisely. We don't have to do any more work on this one. And so somebody tell me how to write the similarity statement.
Triangle X, Y, Z is congruent to triangle S, T, U. Wait,
Yeah. So let's see, X, Y, Z. So this is the longest side to the middle side. Longest side to the middle side, TSU. Yep. So that's the similarity statement. And then what is the scale factor in this order?
3 to 4.
Yep, 3 to 4. If I wrote them flipped, then it would be 4 to 3, but this is fine because we're, again, the similarity statement tells me which order that they need to be written in. Any questions about that one? All right, and the next ones, we're still determining if the triangles are similar or not, and if they are, we're gonna state the similarity, make the similarity statement like this: triangle, blah, 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 similar to triangle, blah, blah, blah. And then we're gonna use or state the postulate or theorem that would justify that answer. So number 10. And these are connected like this, so I drew them like that. All right, so they give us the picture, and then they want us to say if these triangles are similar or not, and then basically state the theorem or postulate that tells us why. So essentially, we have angle, which was the one we had in the last section. We have side, or we have side, angle, side. So which situation would we have here? Yep, side, angle, side. So these are similar. So yes, it's side, angle, side. And then I would just write, these are technically similarity theorems. The angle one is a postulate, but the side, angle, side, and side are similarity theorems. So you can just write like the abbreviation that we used, and then you need to write like sim and then theorem or sim postulate for the postulate one. All right, so then we need to write our similarity statement. So what would our similarity statement be?
Triangle PMS is similar to triangle RMN.
Yep. So we started over here with this one. So I went to the one, I started in the opposite corner, but I started with the one that had the 1 mark on it, and then we went to the middle, and then we came down to the one with the 2. So then over here when we did it, I start over here, go by the one with the 1, hit that middle, the one in the middle, and then we come over here to finish. So that's how I make sure that I'm lining them up correctly and in the right order. And that's all you have to do on those ones. Let's see, 12. So can we tell right away if these are similar or not?
Nope.
Nope, I can't. The other one I could because they were marked as the things were congruent, but I need to evaluate. I know that the angle is the same, right? It's both 110 degrees, even though they look like right triangles. But I could take and I could rotate this one around and look at it, but I need to compare the side lengths. So still the same thing that we were doing up here. I just don't have as many triangles to look at, and I'm only looking at the sides that they give me. So what two sides, what are the proportions that I would be setting up to check these ones to see if they're similar or not?
8/10 and 2/3 is equal.
Give it to me as letters.
CB over LJ is equal to AC over JK. Wait, JK.
Okay, so then we plug in the numbers. So I've got 8 over 10 and 2/3 is equal to 6 over 8. So that's 0.75, and this is also 0.75, or if we reduce this, 3 over 4. So, are these similar? Yes. And then what postulate or theorem works for this one? Side angle side. I only have 3 options, so this one has a side, an angle, and a side. All right, so then somebody tell me the triangle similarity statement.
I'm trying to make sure I get the letters right.
Why don't give me the first one and then just make the other one match it. So start with
ABC,
okay, ABC.
and then it's KLJ, yeah.
Yep. Yep. Wait. Hold on.
Yeah, that's right.
Yeah, that's right. I was having to mentally rotate it in my head.
I know, it's so confusing, right?
It probably, for me, what I just did when I just was, checking it is I took, this one and I rotated it. So then I was like, okay, well, it would look like that. And then I just put the letters where they were supposed to be so that I could, see it. All right, 14.
We don't need the ratio, I think it is, for the last one. I guess not.
All right, so what do we see here with this one?
It's like 2 triangles and 1 big triangle.
Is there something that's really funny over there? Because I don't think that what I'm doing is funny. How about one of you tell me what to do, since you seem to want to have conversation over there.
But X and P and Y and Z are similar?
Possibly.
YZW.
Are you saying that those are the two triangles?
Yes.
So we're looking at
WX, WY.
okay, but do I know if they're similar or not?
No.
No.
All right, so what do I know about what do the parallel lines tell me? Anybody can answer. Okay. As far as the stuff that I need, so I don't know anything about my sides right now, right? So my only option really to look at is angles. So what do I know about like angles in here?
Angle W is congruent to angle W.
Okay, so I would start out with those things. Angle W is congruent to itself.
Angle P is congruent to angle Z
Why?
because lines parallel.
What is the reason though for those to be congruent? What is it called?
I don't remember which one it is. Congruent.
Somebody else can help him.
Corresponding angle.
Yep, they're corresponding angles, so they are congruent. So then we know that angle P is congruent to angle Z. So based on that, what do we know?
If the other two angles congruent, the last one has to be congruent.
Yep, the last ones have to be, and they would be for the same reason. This is also a transversal here, so, or like being cut by a transversal. So those also are congruent. So with all of that information, are these triangles similar?
Yes.
So yes, these are similar, and they'd already put them in, they're already in the right order because we wrote our two triangles to begin with. So what's the reason? Just angle, angle.
Angle.
Angle, angle, similarity postulate. I forgot to write similarity theorem up here.
Proof with no column.
All right, last little bit here. Number 16, these say to, well, they say to draw the given triangle. You don't have to do that part. If you want to, you can. And then it says name a postulate or theorem that can be used to prove the triangles are similar. So it says in triangle ABC, the measure of angle A is 28 degrees and the measure of angle B is 62 degrees. In triangle DEF, the measure of angle D is 28 degrees and the measure of angle F is 90 degrees. And so it wants me to state what I could use to determine that these are similar or not. And that may involve solving for something else.
Angle A is congruent to angle D.
Okay, so I do know that. So angle A is congruent to angle D, so that's going to be something that's helpful.
By the position of the lettering, B is equal to E and C is equal to F.
Well, that might be true, but this isn't a similarity statement.
Angle C is equal to 90 degrees.
How'd you find that?
Because 180 minus angle B minus angle A.
Okay, so 180 minus 62 minus 28 is equal to 90. And so then at that point, we can now say angle C is congruent
To angle F.
to angle F, which confirmed what Michael said that it should be, right? But we needed to confirm that. And so now with that information, what theorem or postulate can I use to prove that these are similar? Angle, angle. Angle, angle, similarity postulate. Okay, now I could also find angle E by doing 180 minus 90 minus 28 and would see that angle E is also 62 degrees, and I could have used that one instead, but I didn't have to do, like up here we really did more than we needed to. We only needed to show that two of the angles were basically congruent. We didn't have to show the third one, but probably the last one to look and make sure. But 18, the ratio of VW to MN is 6:1. In triangle VWX, the measure of angle W is 30 degrees. And then in triangle MNP, the measure of angle N is 30 degrees. The ratio of WX to NP is 6:1. So, do I have enough information to determine if these are similar or not? And if so, what can I use to say that? And if not, what do I need to do?
W is congruent to W. First,
Two different triangles. I already know that the angle's congruent, right? They both have an angle that's congruent. So then I need to look at, this one might be helpful to draw the triangles. Okay, so let's do that. So what this tells me, if VW to MN and WX to NP, if they're both 6:1, okay, that tells me that the VWX triangle is 6 times as big as MNP. Okay, so I'm going to make like a semi-large triangle and then a relatively small triangle just for the visual for myself. I'm going to do VWX like this and MNP like this. And I know that W and N are both 30 degrees, so I'm going to mark those as congruent. So if VW to MN is 6:1, I may not know what the side lengths are, but I know that when they reduce, it's 6:1. So that means that this is 6 and this is 1. And then WX to NP is also 6:1. So that means that, again, same thing. I may not actually know what they are, but that is 6:1. So now that I can visually see that, can I tell if they're similar or not?
yes.
Okay, what do I use to tell that they're
Side
similar?
and side.
Yep. Side angle side similarity theorem. All right. I think that's good. Are there any questions on this stuff? All right. Problems then. 7 through 17 odd. And you should draw the pictures for these because you need to be able to mark on them and all of that stuff. You do not have to draw a picture for 15 and 17, although it might be helpful, like it was with this one for number 18 for you to see it. But the ones that give you a picture, you need to copy them over.
Would I be able to give you a